All right, hello. In this lesson, we are going to be reviewing static and non-static variables. That's the goal here, and then give you some work time at the end. So hopefully it's kind of a shorter lesson. Just going to review some stuff and then work on some programs from chapter 8. So what you see on your screen here are some definitions that have been typed up by students, and I thought these were really, really good, right? Almost better than I can explain it. So I'm actually just going to have you pause the video and read through these about the difference between static and non-static. All right. Hopefully you had a chance to read them. That last one, real good too, is a static variable is associated with the class, not a specific object, and a non-static variable is different for each instance of the class. So if it's a variable that's going to be different, like a name variable is going to be different for each student. So that would be a non-static one. Okay, so just there's kind of two different ways you might use static variables. One is from the example from the other day, which is where you have a variable that tracks the total number of fan objects that have been created. Okay, so the way that would work is you'd have an int that starts at 0, right? Normally inside the class, you don't give them values. You do that when you construct the object in a different class, right? But you could make the static one start at 0, and then each time someone uses a constructor, you just increase that by 1, right? Is that would track how many fans. You could even actually assign it to, like, you could give them a fan ID. So maybe I'll show you what that looks like. So if you wanted to give them a unique fan ID, you could make that be um, a private, so it would be a non-static variable actually. So you could do private int fan ID so that each one has their own unique ID. But what you could do is when they construct a fan, you could increase the number of fans and then their fan ID would just match whatever fan number they're at, right? So you could do it that way. So that's kind of a way to make like a unique ID for each of your objects. And you'd use a variable that starts at 0 and then it's different for each object. Um, but the num fans itself would just be a single counter, and then you could use it to assign it to an ID. That's maybe a little bit confusing, I guess, but the simple thing is just there's only one of these num fans, and it's stored in the class, not in any specific object. It's associated with the class, not a specific object. Even though all the objects have access to it, it is really just associated with the class. Um, but anyways, all right, let's get oops, wrong file here. Okay. Uh, and then this was just a commonly missed one from the review questions. Non-static variables are specific to an object. So that is again true, right? That is a true statement because that's what it means to be non-static is that each object has its own set of data and that data is called non-static data, right? They're non-static variables. All right, so I just want to do a couple more coding examples with you. Um, and so one would be just to talk about a triangle class that we did earlier. All right. And I added a little bit of features here, whatever. But if we had a triangle that had 3 instance variables, base height and num sides, what do you think would make sense? Which one of those would make sense to be a static variable? So you could pause the video and think through that. All right. Um, and the one that would probably make most sense would be num sides, right? Because base and height would be different for each triangle object, but num sides wouldn't. Okay, so this is sort of the second way that you might use a static variable. So the first was to do it with IDs or like a count of how many students or fans or whatever. So that's one way to do it is just track how many fans. But you can also, if something doesn't change ever for a class, you can just make that static, right? So we can do private static int num sides and set it equal to 3 right away because that's always going to be 3 for every single triangle. Okay, and just to make it even more confusing, if you want, you could also make it final because final means it can't be changed. But it also makes sense to be static because you can associate it with the triangle class since every triangle has 3 sides. Okay, in a very similar way, um, you could make a method that's called get shape name, and you could make that static because that's not dependent on any specific, like the base or the height of the triangle. It's always a triangle, so that would just be a static method, right? So you could have a static variable and a static method. Okay, and then how that manifests itself, I go over here to triangle runner, right? So basically, if it is static, right, then I can access it without ever creating an instance, right? So I can call this get shape method without ever making a triangle instance. So I can just do class name, okay, and then I can call the get shape method right away, and boom, it can print out whatever it does in that method, which I think it just says I'm a triangle. Okay, and notice that like this would not make sense. So I do have a get area method that's not static, but if you think about it, if I try to do triangle dot get area, that really doesn't make any sense, right? Because the class itself doesn't have an area, right? The class doesn't represent any specific triangle, just a blueprint, right? So if I actually want to do the area, I have to do it on a specific object, not the class, right? So if I want to call get area, I would need to do triangle, triangle 1 equals new triangle, and I would need to specify like the base and height. Okay, and then once I have a specific triangle, now it makes sense to call that method. So I can do triangle1 dot get area, right? Boom, so now it prints out the area, right? Now that it actually has some data, now that it actually has a base and height, it makes sense to do the area. Okay, and please note, so again, that you access it by doing object name dot method name. Okay, and that's for non-static stuff. For static, it looks like this. You do class name dot method name. That's the static way of doing it. Okay. Please note too that you still can call the static methods from an object, which does make sense. If I do triangle1 dot get shape name, that still makes sense, right? Even though this is an object, not the class, it still has the shape name of triangle. So it still makes sense to call the get shape name method from either the class or the object. Okay, then the final thing I want to do is just talk about like this num sides, right? That's a static variable. So in theory, I should be able to go like, if I try to print that out, so a static variable. So in theory, I shouldn't need to make a class for that. So I can just do the class name. Sorry, I shouldn't need to make an object. So I can just do the class name dot num sides, okay? But it's not letting me do that, right? So see if you can figure out what is wrong with my situation here. Okay, and so the change is you need to make it public. If I want to be accessed outside of this class, I need to make it public. So usually if it's a static variable like that, you'd make it public so that over here, then I can access to it. I should have access to it if I spelled it right. Num sides. So I should be able to do triangle dot num. There it is. Okay, right, and then I can do whatever I want. System out print that, except it's complaining for some reason. Oh no, it's not. Okay. So then I can just print out the number of sides, right? And again, that is always 3, so you can call it from an object, right, or the class, right? Definitely I can do triangle1 dot num sides, right, because that'll always be the same thing. That'll always be 3. Okay, so that's it. That's our review of static and non-static. It's a pretty advanced concept, but it is useful to know. Most of your variables are going to be non-static. Again, the only time you have static is if you have something that is fixed, that's always the same for the class, or like the fan example, where if you want to track how many fans you have, that'd sort of be like a counter. That'd be kind of the 2 ways you might use static variables, at least that I know of. All right, that's it. Thank you for